Hi guys, today we are going to be discussing about Chapter 7, Mutation, specifically on chromosomal mutation. As we have learned in the previous video, we know that there are two types of chromosomal mutation. The first one is chromosomal aberration or change in the chromosomal structure, and another one is change in the chromosomal number. Alright, so today we are going to be focusing on change in the chromosomal number. Okay, so there are two types of change in the chromosomal number. The first one is aneuploidy, okay, which is the condition whereby an individual having one extra copy, okay, 2n plus 1, diploid plus 1, or having less one copy of chromosome, okay, 2n minus 1 or diploid minus 1. Okay, so this is an example of normal female and also a Down syndrome female. Okay, so normal female, just like any other normal human, contain or carry a total number of chromosomes 56, but for Down syndrome female, okay, the total number of chromosomes that they carry is 47. This is because a Down syndrome individual will have one extra copy of chromosome number 21. So you can see and compare here, okay, between normal individual, we only carry 2 copies of chromosome 21, but for a Down syndrome individual, they will always carry one extra copy of chromosome number 21. Okay, alright, so that is aneuploidy, okay, a condition whereby an individual having one extra copy of chromosome or less one copy of chromosome. Another condition is called as euploidy, or also known as polyploidy. Okay, this is a condition whereby an individual carrying extra sets of chromosomes. Okay, like this individual. Okay, so this individual is just like us, a diploid individual. Alright, so what is meant by diploid is that for each kind of chromosome, okay, so there are 3 kinds of chromosome here: big kind, medium kind, small kind, and for each kind of chromosome there are 2 sets or 2 copies, so 2 big, 2 medium, 2 small. But this individual, although there are still 3 kinds of chromosome, you still have big, medium, and small chromosome, but for each kind of chromosome there are 4 sets or 4 copies. As you can see, there are 4 big, 4 medium, and 4 small, making this individual to become 4n or tetraploid. This individual arises from the self-fertilization of 2 unreduced gametes from this individual. So as you might have guessed, euploidy or polyploidy are more common in plant rather than in animals. So that is euploidy or polyploidy. Okay, so now we are going to be focusing on aneuploidy, okay, having one extra or having one less copy of chromosome. There are several conditions that results from aneuploidy. An example of that is Down syndrome. So this is an example of a Down syndrome individual. We can always tell whether that person suffers from Down syndrome condition because they have these very striking features, which we will discuss shortly. Okay, so this individual is 2n plus 1, or in other words, carry 47 chromosomes because they have extra 1 copy of chromosome number 21. So these are the features of Down syndrome individuals. Okay, they have short stature, flattened nose, upward slanting eyes, short and broad hands, growth retardation, and also mental retardation. So we must be wondering, how does a Down syndrome individual come to be? Okay, so they actually developed from a zygote carrying 1 extra copy of chromosome number 21. And how does that zygote have extra 1 copy of chromosome number 21? Okay, so that zygote must be formed from the fertilization of 1 normal gamete and 1 abnormal gamete carrying 1 extra copy of chromosome. Okay, alright, so there must be between 1 normal gamete and 1 abnormal gamete carrying extra copy of chromosome number 21. So let me play that again for you. Alright, now, so which gamete? So is it the sperm or is it the secondary oocyte that is abnormal? This question is actually a less pressing question. It does not matter which one is abnormal as long as it is the union between 1 normal gamete and one abnormal gamete carrying one extra chromosome. Alright, so the more pressing question is that how does the abnormal gamete arise? Okay, they arise from the phenomenon called chromosomal non-disjunction, which refers to the failure of homologous chromosome or sister chromatids to separate during cell division. Okay, consider these three situations. You have situation A, where normal meiotic division happened. Situation B, there is some error in meiosis 2, and situation C, there is an error in meiosis 1. Okay, so take note that in this diagram we are only interested in the movement of chromosome number 21. Everything else happened normally. Alright, so in normal meiotic division, the homologous pair of chromosome 21 divide normally in meiosis 1 and divide normally in meiosis 2, producing normal gamete or gamete carrying one copy of chromosome number 21. But for situation B, where error occurs in meiosis 2, the sister chromatid failed to separate. There's non-disjunction of chromosome number 21 during meiosis 2, so resulting in both chromatids to end up in one gamete. So this gamete will carry one extra copy of chromosome number 21, and this gamete to carry no chromosome number 21. Right. If error occurs in meiosis 1, as you can see, the homologous pair of chromosome 21 failed to separate during anaphase 1. None of the resulting gamete produced will be normal. Okay, so this is just for discussion purposes, but if question come up in the exam, you no need to discuss in detail. You just simply say chromosomal non-disjunction of chromosome number 21 during gametogenesis or during meiosis. So if we are faced with this question in the exam, we know that either gamete can be the abnormal one. So let's say if this time you would like to blame the sperm to be the abnormal one, so we will say this. Due to chromosomal non-disjunction of chromosome 21 during spermatogenesis, of course, because you want to produce sperm, result in the production of abnormal sperm carrying one extra copy of chromosome 21. Alright, and this abnormal sperm fertilizes a normal secondary oocyte. Okay, so that is the answer if you want to blame the sperm. So let's say if you want to blame the secondary oocyte now, so the answer should change a little bit. Due to the chromosomal non-disjunction of chromosome 21 during oogenesis, results in the production of abnormal secondary oocyte carrying one extra copy of chromosome 21, and this abnormal secondary oocyte is being fertilized by a normal sperm. So you can choose either way, whether you want to blame the sperm or you want to blame the secondary oocyte. Another condition that arises from aneuploidy is Klinefelter syndrome. Okay, so Klinefelter syndrome must be a male, but that male individual carry one extra copy of chromosome X, so that individual is XXY instead of a normal male XY. So these are the signs of Klinefelter syndrome sufferer. They must be a male, they have taller body but less muscular body than the males in the same age group. They have broader hips and longer legs, larger breasts, weaker bones, a lower energy level, smaller penis and testicles, delay in puberty or go a parcel amount, less facial and body hair following puberty, and they have high-pitched voice. Alright, so how does a Klinefelter individual come to be? So what are the possible combination of gametes that produces Klinefelter syndrome child? It can either be from the combination between normal secondary oocyte with abnormal sperm carrying XY chromosome, or abnormal secondary oocyte carrying XX chromosome and a normal sperm carrying Y chromosome. So let's have a look how to answer the question if the combination is the first combination. It is due to chromosomal non-disjunction of sex chromosome during spermatogenesis, results in abnormal sperm carrying both XY chromosomes. This abnormal sperm fertilizes normal secondary oocyte. If you want to answer based on the second combination, so this is how you answer it. Due to the chromosomal non-disjunction of sex chromosome during oogenesis, results in abnormal secondary oocyte carrying 2 X chromosome, and this abnormal secondary oocyte being fertilized by a normal sperm, but you have to specify which normal sperm it is because there are 2 types of sperm carrying X chromosome and sperm carrying Y chromosome. So in this case, the abnormal secondary oocyte must be fertilized by a normal sperm carrying Y chromosome, producing XXY zygote. Another condition that arises from aneuploidy is Turner syndrome. A Turner syndrome individual must be a female, but unlike normal female which carry 2 X chromosomes, Turner syndrome female only carry 1 X chromosome. So in total, this individual only have 45 chromosomes. So these are the signs or symptoms of Turner syndrome individual. They are infertile, they are short, they have webbed neck, triangular face, they do not menstruate, and they have underdeveloped secondary female characteristics. So what are the possible combination of gametes which give rise to a Turner syndrome child? It can either be between normal secondary oocyte with abnormal sperm carrying no sex chromosome, or between abnormal secondary oocyte carrying no sex chromosome with a normal sperm carrying X chromosome. So how do we explain the first possibility? We will say it's due to chromosomal non-disjunction of sex chromosome during spermatogenesis, which results in abnormal sperm carrying no sex chromosome, and this abnormal sperm fertilizes normal secondary oocyte. And if we want to explain the second possibility, we will say, due to chromosomal non-disjunction of sex chromosome during oogenesis, results in abnormal secondary oocyte carrying no sex chromosome, and this abnormal secondary oocyte is being fertilized by a normal sperm, but for this one you have to specify which sperm it is, because we know that normal sperm can either be carrying X chromosome or Y chromosome. For this case, the abnormal secondary oocyte must be fertilized by a normal sperm carrying X chromosome, forming an XO zygote, which in turn will develop to form a Turner syndrome child. Alright guys, so in this video we have learned about chromosomal mutation, specifically on change in the chromosomal number. We looked at aneuploidy, which is the condition where an individual carries extra 1 copy of chromosome or less 1 copy of chromosome. We looked at chromosomal non-disjunction and also the various examples of diseases which arise from aneuploidy condition. In the next video, we will discuss euploidy or polyploidy, which is the condition where an individual have extra sets of chromosome.